So welcome to 2016 question B2. So we've the building here in Limerick. Alright, the plan of the building is based on an ellipse, okay, reflecting the rugby tradition of the city, and the top is based on a parabola. Okay, part A, draw the given plan elevation of the structure. So I'll show you a quick model of the solid just to give you an idea of it. Right, there we go, and we have to draw an elevation. Okay, there's the parabola there, you can see in the top, and there's the plan. Right, now the plan has to be 15 mil from the XY line, okay, and it's based on the ellipse, so we're going to use the concentric circles method of drawing. The radius, okay, of it is going to be 50, and the radius of the major circle is going to be 50, and the radius of the minor circle is going to be 30, because the scale 1 is to 100. Okay, and we're going to get started. Sketch the points in the curve in. So we have the ellipse drawn in, and then the line that represents an edge of the vertical cutting plane, the plan, pass it through the vertex of the minor circle. Now we can project our lines up. Okay, the height is 180. Now, first one is up, as the start of the parabola is up 140, and then the height of the parabola is a further 40. So we're going to use the rectangle method to construct this parabola. Now, we're going to divide the parabola, okay, up into equal divisions. Now, because it's 50 in width, or the rectangle rather, I'm going to go every 10 along the bottom, okay, and I'm going to draw vertical lines up. And then I'm going to divide this edge up into 5 equal parts, and it's 40 in total, so 40 divided by 5 gets me 8, so I'm going to mark every 8 on it. Now we're going to mark these points to the vertex A. And then these are the points on our parabola. And we can freehand sketch those points in a moment. And then you can do the other side as well, mark them in tens. Just bring these points across. So we can freehand sketch them in. So the curve drawn in, and then I can heavy that line down, and this one here on the left. Okay, and then the next thing you have to do is the end elevation. So the next part of the question, you have to draw an end elevation looking from arrow B, so looking from the left. So that means that you have to project what you see onto the right. Okay, so the end elevation will be drawn on the left, or on the right of the elevation as you're looking from the left, and the vertical section will appear as hidden detail. Okay, and that's how the curve is going to appear. So I'm going to ignore the, I'm going to draw the outline end elevation and ignore the curve for a moment. So I'm going to draw in something called the YY line. So the 5-3 line. Now I'm just going to label these 2 points here, 1 and 2, A and B. This is A/B, and this is 1/2 in elevation. Then A and B I have to bring up over to the 45-degree line and transfer over to end elevation. Okay, and then I can transfer my heights over from elevation. Okay, now it's going to be 1 to 2 is going to be heavy here. A to B, okay, it's going to be hidden detail in here. And hidden detail here for the yellow surface. Right, so there's the outline, end elevation. We just have to draw on the curve. This is the apex of the curve, the vertex of the curve, right there. It's just brought across and it's right in the middle. Now, how we're going to find this is we're going to slice this object horizontally to establish a set of points. So I'm going to bring this up here. So here I have a cutting plane, and where this cutting plane pierces the parabola in elevation, I'll have 2 points in plan just along the cutting or along the curve, and it'll remain on the same height in elevation. So I'll show you what I mean by that. So there's where the cutting plane, this plane 1, intersects the solid, and these are the 2 points here that I'm referring to. Now that's them in plan, okay? So I'll just do one of them here. That's it in plan, and look at the height of it in elevation on that plane, and it remains on the same height in end elevation, and it's a little bit in. So on our drawing, we're going to take 2 points here. I'm going to take this one and this one here. Right? I'm going to call this C/D and E/F. Okay, and that's G. You don't need to do too many. So C and D across, E and F across. Now I need to find those points in plan. So that's F and that's E. Okay, that's D and that's C. E, C. F, D. So C across to the 45-degree line, all the points across. Now we're going to bring them straight up. So I'm going to bring D up to the altitude of D. So there's D. F up to the altitude of F in elevation. Then E. C. And then what was the other one we were doing? E. Okay, and then that's G. Now I can freehand sketch those points in, so I'm going to pause and do that now. So that's the end elevation drawn in. Now the next part of the question says, okay, that there's an architectural feature in the form of a steel band is to be constructed on the outside of the building. Okay, the VT and HT, so the VT and HT are traces of an incline cutting plane used to define the position and shape of the steel band. Right, what does that language mean? So this is what the language they're saying there means. There's the VT there on the vertical plane, okay, and there's the HT there on the horizontal plane. Now an inclined plane passes through both of those lines, so that's where the inclined plane intersects the vertical plane and the horizontal plane along those two lines. Now here's the band, so there's the band. Okay, now we're being asked to find the true shape of that band basically, so where the plane cuts that building. So look, we're being asked to find the true shape of that cut surface. So what we're going to have to do is drawing the VT and HT, and we're going to then need to see the cut surface as an edge in order to be able to see the true shape. Look, so we're going to need to see it as a edge view in the end elevation. That's why they asked you to get the end elevation. So the HT is up 12 millimeter, 120 millimeters from the XY line, as per the video, or as per the question, and then the HT is down 90 millimeters from the XY line. So there's our HT, and here's our VT. Now, look, where they intersect the YY line, that's going to be their position in end elevation. So that's the VT in the elevation, and then in the end elevation, this is where the HT will be, and then they connect together. So that's the surface, that's the cut surface as an edge. Now, there's two ways you could do this. You could rotate the cut surface down, bring it down to your 45-degree line and across, and drop it down from plan. That takes an awful lot of space, so it does a massive amount of space. Okay, I suppose what's most likely is to look for students is to look perpendicular to the cut surface. So it is to find the true shape. So I'm going to look perpendicular to the cut surface to find the true shape. So I'm going to take my set square, alright, I'm going to project perpendicular to it. And then I'm going to, so they'll be my projection lines. But first I need to establish a set of points. So I've labelled these points in plan, and we need to get them on the cutting plane in end elevation. So this is where this question gets difficult with the multitude of points. So if you pick too many here, it would be quite hard here and in plan. Now you could use the same points again. I just find that it's just awkward for me afterwards by them being too tight together. So I'm going to bring them up to end elevation. I'm going to label them points in now. So I've marked in the points. I used some of the same labels again, okay, but just different colour pen to help myself, and I used A1 and B1 for the points on the bottom there. Now I'm going to project all those points perpendicular to the cut surface. So I'm going to carry on and project all of them. So that's the question complete. I'll heavy in the lines now.